Okay, lesson 14. Sorry, I cut you off, Mallory.
You did.
Limits of a function. I believe we talked a little bit about limits previously, and we talked about limits that time we were looking at a visual graph, correct?
Yes, ma'am.
And how we work about limits, how we talked about x approaching number from the left, x approaching number from the right, what all that means. So, as I said, limits is one of our 3 big core topics in calculus. So, we will start to dive into this more and more. A function has a limit at a particular value of x if it has both a left-hand and right-hand limit at that value of x, and these 2 limits are equal. Meaning, if it doesn't specify, as x approaches 2 from the left or as x approaches 2 from the right, if it just says as x approaches 2, the idea that as that limit approaches from both sides, they have to meet in the same place. Okay, so for that limit to exist, they have to meet in the same place. If we want to know the limit as x approaches 2, but I've got one limit approaching up here and the other limit approaching down here,
We don't know how
that limit does not exist. Okay, the individual limits can exist, but the limit as a whole would not exist. Now, part of what that means is that these need to be, I'm going to throw in the word continuous. Okay, so for a limit to exist, gosh, I feel like that's really sloppily written, but we need to be talking about continuous functions. And that is actually part of our definition for is a function continuous, and it's continuous if the left and right hand limits meet. Okay. So, if f of x equals x plus 6, we want the limit as x approaches 3 of x plus 6, which basically they defined f of x to be x plus 6, correct?
Yeah.
So this is really saying, what is the limit as x approaches 3 of f of x? We talked about how to do this? Okay, without a graph?
No, we know with
Okay.
graphs here.
So, first of all, if you think about the function x plus 6, here we go, I'll tie it in. What is the function x plus 6? Like, what is this? Y equals x plus 6. See, I'll tie it in, which is in the form y equals mx plus b, right? Okay, there we go. I tied it in. Now, the idea now is as x approaches 3, what is the value of this equation? Okay, there are certain equations this doesn't work. There are certain limits this won't work, okay, more complicated limits. But a basic, just polynomial basic function, nothing special here. Easiest thing to do is to take the 3 and plug it in for x. So if I take 3 and plug it in for x, 3 plus 6 is 9. If we were to graph this and look on a calculator, y equals x plus 6, well, when you look at where x equals 3, what is the y value at that point? And the y value is 9. Okay, so one of our shortcuts of limits is if it's just a, not a, I don't know, nothing where you get weird answers. And that'll make more sense in a moment. I'll just be quiet there.
Why does it look like it'd be way more work?
Limit, as I said, limits, they can be confusing, but they can also be very easy. There are definitely a lot of easy parts. So, okay, let's look at the next one. If g of x equals x squared plus 3, what is the limit as x approaches 3 of x squared plus 3? So this is saying, what is the limit of g of x as x approaches 3? So what do you think we're going to do here? Plug in 3. So now I'm going to have 3 squared plus 3, which is 12. If you look at that x squared plus 3 graph, so that parabola, where x equals 3, the y value is 12. And so that's what it's approaching. Okay?
I wish I had 25 minutes.
Me too.
Okay. Now, we just found up above the limit as x approaches 3 of f of x to be 9. We just found the limit of g of x as x approaches 3 to be 12. Based on that information, here are some basic rules about limits. Each of the following would then work out. The limit as x approaches 3 of f of x plus g of x. Don't think too hard. Take it easy. How am I going to find the limit of f of x plus g of x?
9 plus 12.
9 plus 12. Okay, so the idea is, how did I say it? The limit of the sum is the sum of the limits.
I like that.
But, so officially, and I won't do this on all of them, this is saying, this is the limit of a sum, two things added together. It is equivalent to the limit of the two individual
At
pieces.
this time, anyone who has not got their picture taken needs to report to the high school gym. Anybody who has not gotten their picture taken, please report to the high school gym.
Did they already bust through middle schoolers?
I heard them say
No, I think they've already been to school. I watched
They probably
I
did.
got their picture yet.
Yeah, I'm pretty sure they did.
Yeah, but they wouldn't call down an entire,
That was
like,
the fastest time I've ever gotten my
I never
picture. I
heard
walked in
sixth
there,
grade.
literally walked in there, took off my mask, smiled, and left. Like, look, you put I didn't even look at it, I just walked in.
okay, so the sum of the limits, this is the limit of the sum, so it's the limit of two things added together, is equivalent to the sum of two limits added together. And this is, they're both approaching 3. So, as you guys already said, 9 plus 12 is
Was not close.
21. Your teacher has an issue with 21, but okay. I think it looks like a 21 now. So, take a guess about the subtraction one. The limit as x approaches 3 of f of x minus g of x. Okay, it's the two limits subtracted. So 9 minus 12, which is negative 3. The limit of f of x times g of x.
9 times 12.
It's going to be the limit of f of x times the limit of g of x. 9 times 12, which is 108. And division. The limit of f of x divided by g of x is the limit of f of x divided by the limit of g of x. 9 divided by 12, which would be better written as 3/4.
My brain is getting it today.
Yeah, but wait till the homework. It's all going to be like the volume of cylinders or something.
Okay, moving along. Graph x squared minus x minus 6 over x minus 3 by hand. And technically this should say y equals, because you can't really just graph an expression. It needs to have an equation. So this really should say y equals. Okay, top of your head. Any thoughts what this graph looks like?
There's going to be a hole at 3.
Okay, so one thing I heard, there's going to be a hole at 3. How do we know there's going to be a hole at 3? Okay, and right there, I'm going to generalize it more, and I'm going to say there's going to be some kind of break at 3. My options are vertical asymptote or hole. Vertical asymptote, hole, or when the denominator equals 0. What's the difference, though? Okay, and how do we know based on this equation that it's a hole and not an asymptote? Nathan, did I hear you say something about it's going to be a line? How do you know it's going to be a line? Okay. Factor this numerator. You guys are seeing the pieces. I'm impressed. X squared minus x minus 6. How does that numerator factor? X squared breaks into x and x, multiplying to be -6, adding to be -1. X minus 3, x plus 2.
It should have been canceled. It's a whole
Okay, so the x minus 3's cancel, leaving me with the equation y equals x plus 2. Can you agree that Nathan said this is going to be a line? Yes? Except, what's the catch? Because x minus 3 was in the denominator, and this x minus 3 canceled, it is a whole at x equals 3. And Logan pointed out, again, we get to talk about y equals mx plus b. So, it said to graph this by hand.
Oh, I miss graphing lines.
Okay, y equals x plus 2 means we need a y-intercept at 2, a slope of 1, rise 1, run 1. Do I need to remind you? Surely not at this point. Now, when I draw this line, what's the catch? Yeah. Right here is 3, yes? So wherever that is, there is a hole. Let's see. You guys are on year 2 of graphing calculators, so you realize we graph this, we're going to get a line. Are you going to be able to see the hole in your graphing calculator? Maybe, maybe not. Don't count on it is what I will say. There is a chance you'll be able to see it if you zoom right and everything, but I never count on being able to see that kind of stuff. So that's where you have to recognize, oh, denominator. There's a denominator here. Set that equal to 0. It's either got to be an asymptote or a hole. Since we simplified to be y equals x plus 2, it is a hole. Okay, so what would be the limit here? It doesn't ask this, but I'm asking this. What would be the limit of this function as x approaches 3?
Yeah, I got it.
Oh my goodness.
You started at 2 instead of you moved 2, 1, 2, 3, 4, 5. Just add a little tick under it. It's okay.
Okay, so yes, I was stressing over why is mine not visually appearing to be 5. Did you guys do your graphs right at least?
Yeah. I did mine up to 8 on both sides.
Oh my gosh. So your teacher screwed up.
I need to find these to find out.
Okay, I am moving. Okay, so if that's 2, this is 1, and something like that is my x-axis. That's not exactly right, but you know. Okay. Better?
Yeah, that's beautiful.
Okay, so now, as x approaches 3 from both sides, we're approaching this hole, yes? It's a hole, that's okay. And it approaches at the y value of 5. So the limit as x approaches 3 is 5. Now, here's the issue we're going to run into today that we have to manipulate algebraically. The limits up above, I said basically plug the number in, right? Well, if we were to plug 3 into our original function, Let's plug 3 in. 3 squared minus 3 minus 6. 0. 3 minus 3. 0. We got 0 over 0, but yet we just proved that limit is 5. And this is where the importance of what happens if we would have factored and canceled. Now you have a reduced version of y equals x plus 2. You plug in 3. 3 plus 2 is 5. And it does work.
Last call for people that have not gotten their picture taken yet. Please go to the high school gym. Last call.
Okay. So, with all of that in mind, let's look at example 1. Evaluate the limit of x squared minus 4 over x minus 2 as x approaches 2. So, based on what we started with at the beginning of the period, you would guess that you should what? Plug in 2. So, if we plug in 2, 2 squared minus 4 over 2 minus 2 equals 0 over 0. Does that mean that this is undefined and we're just done? We can't do anything? No. Best bet here to start is to investigate algebraically. Okay? Is there factoring and then more importantly canceling that can happen? Okay, so I'm going to rewrite this. The limit as x approaches 2. What do we know about x squared minus 4? It's the difference of squares. X squared breaks into x times x. And 4, the square root of 4 is 2. So we have an x plus 2 and an x minus 2 over the x minus 2 that's already there. What's so nice? There's a hole at x minus 2. So we're going to cancel our x minus 2. Now this becomes the limit as x approaches 2 of what remains? X plus 2. Now can I do it?
Yep.
Yeah. Plug in the value. 2 plus 2 is 4. Now keep in mind, because it says x approaches 2, there would actually be a hole there, but it still approaches from both sides. It still goes back to a linear form. Are we still okay with this then?
Yes, ma'am.
I mean, look for the factoring. That's going to be the key today. Okay. What about example 2? What are your brains trying to do right now?
Well, it's not 0 over 0, it's still impossible.
Okay. He says it's not 0 over 0, but he still doesn't trust it. Did you try factoring? I mean, if we try factoring here, there is a little bit of factoring, isn't there? X squared plus 2x has a GCF of x. So then we factor out x and we have x plus 2 over x plus 1. Do any factors cancel? No. So even though Logan doesn't trust it, whether you use the unfactored form or the factored form, plug it in. So if I plug in 3, I could have done it to the original. 3 squared plus 2 times 3 over 3 plus 1. Did you guys get what I got? 15/4. And notice you could have plugged it in either way there. Okay. So don't let it scare you off. Ready for the back side? Okay, limit as x approaches 3 of x squared plus 6x over x minus 3.
Three on the bottom will cancel the zero. So should we do-
Okay, so what are you guys doing? Plugging in?
Yeah.
Okay, so if we plug in 3 squared plus 6 times 3 over 3 minus 3, which is 27 over 0. What is 27 divided by 0? Undefined. 27 you can't divide by 0. Okay? Was there a factoring option that helped? I mean, the factoring I could have done is to factor out x. Then I have x times x plus 6 over x minus 3. Does anything cancel? No, nothing cancels. So, this is our first example of, algebraically speaking, limit does not exist. Because we are trying to divide by 0, which can't be done, limit does not exist. Okay, so real quick, I might have to turn off my plot that I'm using in my other class, but I typed in this to the graph because I just want you to see. Okay, ignore the dots. We're doing stat plots in pre-calc. Slowest graph ever. Okay, I'm guessing I can't see. There's another part of this I can't see. So the question is, as x approaches 3. Let me zoom out. Slowly. Very slowly. There we go. There's the other part. Does it make sense that we came up with the answer that the limit does not exist? Yeah, because what's happening at 3, first of all, there was no, x minus 3 didn't cancel with anything, right? So that means there's a vertical asymptote. Now, if both sides of the vertical asymptote are going the same way, we could talk about something different. We could talk about infinity, but that's not where we're at. We've got one side going up to positive infinity, the other side going down to negative infinity. Those are going not the same direction, and so my limit does not exist. Does that explain what we just did? Okay, because this goes down to, you need to understand how this works out algebraically, because you don't always have the access of the calculator. Okay? You know, when training you for AP tests here, you only have the calculator 50% of the test. So, okay. Example 4. Thoughts on example 4? What? Okay, plug it in. 2 minus 2 over 2 squared plus 4 becomes 0 over 8. What is 0 divided by anything? 0. 0 on top is always 0. I just realized that. Should have said as t approaches 2. Did this factor anyways? I think Nathan was trying to factor it at first. If it was t squared minus 4, we'd factor. T squared plus 4 does not factor. So, 0 is a number, guys. My answer to my limit is 0. As t approaches 2, so as our t or x value approaches 2, the y value is going to approach 0. Okay. Moving along until you guys stop me otherwise. Example 5. The limit as x approaches -1 of 2x squared plus 5x plus 3 over x plus 1. Well, if you just try plugging in the -1, you're going to have a 0 in the denominator, right? Now, I believe you get a 0 on top too, don't you? Yes. So we have 0 over 0, which is one of our undefined forms. We don't know what that means. So what should we try doing? What are you guessing I'm going to say about that numerator? It factors. Now, okay, be smart. If my denominator is x plus 1, what would you guess is going to happen in the numerator? Could one of the denominators likely be x plus 1? And isn't this a product sum type problem? The catch is that it is a product of AC. So you can work it out as product of AC if you want. But I'm also going to use my sparks here. And okay, we know 2x squared breaks up into how? 2x and x, yes? What would 3 have to break into? 3 and 1. Now, for this problem to work, what do you guess is going to happen? The 1 is with the x. The 3 is with the 2x. Multiply to be positive, add to be positive, both pluses. Now, I would suggest before you proceed, does that FOIL back together correctly? 2x squared, I'd have outsides of 2x, insides of 3x. Oh, 2x and 3x is 5x. 3 times 1 is 3. If you don't like what I did, then by all means, product of AC it. Okay? Logan, you don't appear sold. Okay. Are you just liking the fact the way I skipped the steps and...
Yeah.
Okay. And as I said, if you don't like what I do, just product of AC it. And we can review that at some point if we need to too. What's the point though that happens here, regardless of whether you like my factoring or not? X plus 1's cancel. So we're left with the limit as x approaches -1 of 2x plus 3. So 2 times -1 plus 3 is going to equal 1. Numero 6. Limit as x approaches 2 of x cubed minus 8 over x minus 2. Okay, if you plug that 2 in right now, you get 0 over 0. No? X cubed minus 8 should be recognized. X cubed is a perfect cube. What about 8? 8 is 2 cubed, so 8 is a perfect cube. There's a subtraction sign in the middle. This is difference of cubes. This factors. This factors into a binomial and a trinomial. Sound familiar? We used the F and S thing earlier on to talk about it. I don't know, one of our first beginning lessons. So, binomial. The cube roots. What's the cube root of x cubed? X. Keep the given sign. So since it's a minus in the problem, we put a minus in that first factor. What's the cube root of 8? 2. So my binomial is x minus 2. Oh, coincidence? Okay, now, to get your trinomial. Your first term is the first cube root squared. So x and square it becomes x squared. This next sign is the one that always changes. If it was minus in the last parenthesis, it is plus in this parenthesis. And now it's these two cube roots multiplied. So 2 times x is 2x. The last one is always a plus because you're squaring something and you're squaring the other cube root. So 2 squared is 4.
So it wouldn't be plus negative 2x.
Say what now?
So it's x squared plus 2x, but it wouldn't be x squared plus negative 2x.
You could think minus negative 2x. I mean, if you always wanted to think, okay, this sign's always a minus, and then you take this sign on top of it, maybe, if you wanted to come up with a technique like that. Which, you know, I mean, I could see doing something like that. The way I explain it to you is just the way my brain thinks about it, but there is a little bit of a memory. You know, you have to memorize a little bit there. Okay. I don't think I need to tell you guys. You see where you're going from here, don't you?
Yeah.
X minus 2's cancel. The limit as x approaches 2 of x squared plus 2x plus 4. Now we can plug our 2 in. 2 squared plus 2 times 2 plus 4 is 12.
Period.
2 squared, so 4 plus 4 plus 4. Okay. Example 7.
Well, if we were just plug in the 0, it would be undefined.
Okay, so I agree. Start by, can we just plug in the 0 and get the easy way out? So if we plug in 0, we end up with 0 over 0, which is we need to investigate farther. Okay? What are our options here? Okay. Yeah, the universal way everyone's going to be able to see is you can FOIL the 3 plus x and simplify from there. I have another way, but it might get confusing in that this is a squared minus a squared.
Yeah.
So you could call it the difference of squares, which we'll go ahead and FOIL it, but the square root of 3 plus x squared, so it'd be 3 plus x in the beginning of each parenthesis. Square root here is 3, so it'd be 3 in the end of each parenthesis. One has a plus 3, one has a minus 3. It's kind of what it looks like. You would end up cleaning up quite a bit, though. So, in the meantime, let's just FOIL. 3 plus x times 3 plus x. So, the limit as x approaches 0, and you will notice, it's a good habit to be in, I am always rewriting the word limit in front. Because it is so easy to get to the end of a problem, you've simplified it all, and then you forget to actually do the limit because you dropped the word limit off. Okay, if we FOIL this, 9 plus, insides and outsides are 6x, plus x squared. We still have minus 3 squared, which is minus 9. Clean that up. And I have the limit as x approaches 0 of, what do I have on top? X squared plus 6x over x. Oh, that's looking much neater. Still, though, if I tried to plug in 0, I would be at a loss. But now we can factor. Yep, factor out the x. X times x plus 6 over an x. The x's will cancel. So it becomes the limit as x approaches 0 of x plus 6, which is 6. So 0 plus 6 is 6.
So I have a question.
X
So first, like, you know how it's like the minus the 3 squared? So like I was like looking at it and I was just wondering if like you could have already canceled out the 9s from the beginning almost. So I don't know, whenever I was first looking at it.
Well, you still would have to FOIL it
Yeah.
first, though,
Yeah.
before you cancel that out. Okay, example 8 says to check your answer for number 7 by using your calculator. So I'm graphing it. Go back to Zoom 6. Again, ignore my stat plot dots. Okay, how does this work? How do we check it? As x approaches 0 means I look at the x value of 0, right? And then actually I'm going to zoom in a little bit so we can see this. So as x approaches 0, that means as we approach the y-axis from either spot, right? That's where x equals 0. And then what do we know? What's our answer there? Whatever your y value is. Well, what y value is that trying to approach? There we go. Sorry, my stat plot. Notice, from the left, I'm at negative 0.037. I'm at 5.96, right? From the right, I'm at 6.03. So what are we approaching? 6. Notice, at 0, there's a hole. But it does approach there. So, if I just sketch a graph, basically what I need is 1, 2, 3, 4, 5, 6. I can. I'm just doing I didn't do anything fancy on my graph. I just basically drew a line going through 6 there, showing as x approaches 0, my y value is approaching 6. Okay? Sorry. 45. I was stressing like, man, where did all of our time go? This was not a hugely long lesson. We should still have time. Forgot.
Yeah.
It's not like a 30, 33. It's 45 that we get out.
Oh wow.
Okay. Limits. Work with them. We will continue adding on to limits, okay? We're doing the basics here, so we will continue adding on.